All right, so there's one last topic I would like to talk about, and that is Venn. No, that pencil I wanted. Oh, that's what I wanted. Venn diagrams. Wow, that looks like crap. Okay, let me choose a different tool. This, that. Okay, so Venn looks much better. Diagrams. And so, what is a Venn diagram? Well, it's basically a nice way for us to visualize sets. Now, since I've already introduced universal sets, I'm generally going to draw them with the universal set. So, what we do is we draw a square to represent our universal set, and then anything to represent any other set inside, we will just draw a circle. Okay, so this just says that A is a set inside of the universal set U. But this is also useful because it allows us to draw a couple of sets. So if I'm talking about two sets A and B, this is sort of the typical picture we'll draw. That's the set U. Here's A, and here's B. Okay, now we can talk about these sets A and B and how they relate to each other. A third sort of picture we'll often see with Venn diagrams. Let me write U outside this time. We can have three circles that's supposed to connect. Here's a second circle, and here is a third circle. And this I'll call A, this guy will be called B, and this guy will be called C. And this is about the most general picture that we can draw, or the best picture that we can draw for the number of sets. Once you have four or more sets, it's really hard to draw the most general sort of picture that can exist. But anyway, so this is just a way of saying, okay, A is a set in U, A and B are sets in U, A, B, and C are sets in U, etc. Let's see. So Venn diagrams give us a good way of visualizing, say, unions. So if I'm going to draw a Venn diagram, again, I just like to draw my universal set there, although it's not entirely necessary. These are two sets, A and B. Now I'm going to shade A in one color, and I'm going to shade B in another color, and then A union B is going to be shaded in a sort of the combination between the two. So let's shade an A all pink-like. Okay, that's A. So A is going to be shaded in nice pink like that. Okay. Then let's let B get shaded in all like blue. Okay. So B gets shaded in all blue-like. Well, A union B is everything that's an A and B or in both. So A union B will be everything that's gotten shaded in pink, blue, or both. So A union B is all three of these pieces that got shaded in. Okay. Now let's look at intersections. Well, let me just use the same picture over here. I shaded an A all pink-like, I shaded an B all blue-like, and then what is A intersect B? It's anything that got shaded in twice. So this time, it's literally anything that got shaded in pink and got shaded in blue. So it's everything that came out this nice purple color. So again, A union B is this whole thing right here. It's this whole shape that looks like this. Whereas A intersect B is this sort of lens shape right here. Now note that we can use Venn diagrams to sort of illustrate things. So for example, disjoint sets I can illustrate by having them not touch each other. Here's A and here's B. And this means that A intersect B is the empty set because they don't touch each other. If I were to look for their intersection, they wouldn't share anything, so it would be empty. Similarly, I can do, say, subsets. If I want to say that A is a subset of B, I will draw A inside of B. So here's A, here's B, and this means that A is a subset of B. Great. Cool. Now, Venn diagrams can help us draw more complicated versions of sets. So, for example, let's draw a... Oh, wait, I wanted to look at one more basic thing we've already looked at. Finally, complements. So if here's my universal set U and here's my set A, well, my set A bar, or excuse me, A prime is everything that's outside of it in terms of Venn diagrams, but let me just shade in here in green. This is going to be the complement. Which this highlighter wasn't always at a diagonal. It's hard to draw over in the corners over here. Anyways, so what is A bar? It's everything that got shaded in that lovely color of green, or excuse me, A prime. Okay. Alright, so now we can do some more complicated looking sets. Let's say I wanted to graph, illustrate A, let's say, intersect B bar. Well, let me draw a, I'm not even going to bother writing U this time, but let me just draw A and B. So here's A, here's B, and I'm going to shade what A looks like and what B looks like, or excuse me, B prime looks like. I keep saying bar, I mean prime, excuse me. So I'll shade A this nice color of pink. There we go. This is A. And then I will shade B bar just because I seem to have been doing this. I'll shade it. B bar is everything that's outside of B. I'll give it this nice color green right here. Notice that I'm staying outside of B, but parts of A actually do get shaded in. So then what ends up being the intersection between, excuse me, what ends up being the intersection between A and B prime? It just ends up being this sort of gray colored shape right here. That's what it is. It's the sort of Pac-Man shape. So it ends up being this Pac-Man shape that ended up being shaded in this lovely greeny, pinky, gray color. Nice. That's what A cap B prime is. Okay. Let's also show that we can use Venn diagrams to show that different thing, some sort of two sets that might look different are actually the same. So A union B prime is equal to A prime intersect with B prime, and let's show this. The way I'm going to show this is I'm going to have two Venn diagrams and show that I end up with the same thing. Okay, so here's Venn diagram number 1, and here's Venn diagram number 2. So A union B, we already know what A union B looks like. It's everything inside of this sort of MasterCard logo. A union B is everything inside of here. So if I'm going to take the complement, everything that is outside of A union B, it'll look like this. So I'm not going to label it this time, but this is, maybe I should just label it. This lovely green color here is A union B prime. Because A union B is everything I didn't shade in, so prime is everything outside of that. Now A prime intersects B prime. Well, let me literally write down what I'm going to shade at A prime and B prime this time. So let me shade A prime, let me shade it pink. So actually first I have to write A, so this is A and this is B. What is A prime? It's everything that's outside of A, so here it includes part of B. That's what it is. It's everything that's outside of A. And B prime, and so that's what A prime is. B prime we're going to let be this blue color, and it's everything that's outside of B. So it includes parts of A, but it doesn't include anything that is in B. So I'm shading everything outside of B. Now what is then their intersection? A prime intersect with B prime is anything that got shaded in twice. Anything that got shaded in this lovely color of pink for being in A prime and the blue color for being in B prime. So it's this whole outside area. Since this purple area is the same thing as the green area, we've actually shown that yes, these two guys are the same. Great. Now, finally, we can use Venn diagrams to sort of help us do different sort of counting problems. So this is sort of an example. In the United States, we have a total of 30 states that have a water border. I mean, both seawater, an ocean, or the Gulf of Mexico, or even, say, a Great Lake. And we have 15 states with a foreign border, either Mexico or Canada, of course. And we have 9 which have both. So here I'm going to let W stand for water border, F stand for foreign, and so I'm saying that there are 30 things in water, 15 in foreign, and there are 9 in both. Now let me set up a Venn diagram to describe this. Now my universal set here, US, that does not stand for universal set, that stands for United States. And here I have those guys which have water border, and here I have those guys which have foreign border. Now W intersect F are those that have both water borders and foreign borders. So W intersect F are those who have both. Now, to help me count things, I'm going to write a 9 in here to indicate that everybody who has a water and foreign border, well, there are 9 of those guys. Now, this piece right here represents those which only have a water border. Since there are 30 total that have a water border, 30 minus 9 gives me 21 which only have a water border. Similarly, there will be 6 who only have a foreign border. Finally, since there are 50 United States, and this accounts for 36 states here, 21 plus 9 plus 6 is 31, there are 14 states which have neither water nor foreign border. So, because all those numbers need to add up to 50. So then you can ask questions like, ones which, how many border only states? 14, because the other 36 won't border both a water and a foreign. Okay, that's it.